we're going to talk about translations, transformations, and reflections. And in order to talk about those, we have to introduce a concept of parent function. A parent function is a function in its most bare bones position where we haven't moved it around, we haven't stretched it or shrunk it or flipped it. So let's give an example. That right there, we all recognize as a quadratic. And the parent function of this quadratic would be, it's just how our input relates to our output. We square everything. So we're sitting at 0, 0, and then we go up to 1, 1, and 2, 4, and this is the parent function. Now, translations of a parent function do not change its shape at all. They simply move it around in space. So to the left, to the right, up and down. That's what a translation does. So let's go ahead and give some examples of that. If I were to take this parent function and I were to add 4 to my x squared, and I want you to note something. There is adding 4 to my x squared, and then there is also adding 4 to my x and then squaring it. Okay, those are two different situations. In the first situation, I am taking my x squared function and I am moving it up 4 units. So when I add it to the outside of my squared, I am changing the vertical positioning. So I would count up 1, 2, 3, 4, and that would be my new 0, 0. And then my shape would look exactly the same. So I wouldn't have changed anything in terms of the width or flipping it or anything like that. Okay, now down here, I am adding 4 within my squared. I'm adding it directly to my x. When that's the case, that is a horizontal shift. Now, vertical shifts happen exactly as you would expect them. If it says +4, you move it up 4. If it says -4, you move it down 4. Horizontal shifts are the opposite of what you would expect. If this says x +4, that is actually moving it 4 units to the left. So, same function, but now it starts here. If this said x -4, you're moving it 4 units to the right. Okay, so our next term, transformations, change the size, shape, and orientation of our parent function. So let's go back to our parent parabola. Transformations come in the form of the following, where I am multiplying a number to my function. And once again, I can multiply it to the x squared, in which case we will be talking about vertical transformations, or I can multiply it directly to the x and then square it, in which case I'm talking about horizontal. And just as before, the vertical transformations do exactly what you would expect them to, and the horizontals do the opposite of what you would expect. So a vertical transformation of 2 means I am stretching this function by a factor of 2. Everything is going up faster. And then if instead of 2, this said 1/2, then I am shrinking this. So everything is gonna go up more squatly. With my horizontal, if my parent function looks like that, multiplying by 2 might make you think that horizontally you would get wider, but with our x's, everything's the opposite. So this is actually horizontal shrink by a factor of 2. So we get narrower. And if instead that said 1/2, we would get wider. All right, so those are our transformations. They change the size, the shape, and the orientation. Finally, let's take a look at reflections. A reflection flips your parent function over a line of reflection. So again, for example, if we have our parent function and we multiply by -1, Okay, now let me remind you, order of operations. We do our exponents first, then we do our multiplication. So this negative is a vertical reflection. It is affecting the x squared. And in a vertical reflection, every y that was positive becomes negative. So we are flipping it over the x-axis. Now, if we were to put parentheses so that that negative is affecting the x, now we're doing a horizontal reflection. And in the case of a parabola that's sitting here, this would flip over to here, and this would flip over to here. So a horizontal flip when we are centered at 0, 0 looks exactly the same, which if you look at this equation makes sense because every negative x that gets squared will come out exactly as an x that gets squared. So now let's take a look at a couple that put some of these things together. So let's say we have y equals negative parentheses x minus 4 squared. All right, parent graph, just a plain old parabola. So let's work with our translation first. X minus 4, the 4 is applying to the x. This is horizontal. Horizontal shifts are the opposite of what you'd think. So negative means we're moving it in that direction. So that's our first shift. Next, we have a flip, a reflection. And so I flip that over the x-axis, and that is my final answer. All right, let's take a look at another one. Y equals 2x squared minus 3. All right, parent centered at 0, 0. Let's take a look at my translation. This is outside of the x squared, so it is a vertical. Minus 3, vertical goes just as you would expect it. Move it down 3 times 2 on the outside of the x squared. Again, that's a vertical. Vertical goes as you would expect it. It is a stretch by a scale of 2. And so that's our final answer. And of course, this right now is just for helping you understand the general shape. To get the specifics, you would go ahead and make a T-chart and you'd enter some values to figure out exactly where these points are, or you'd work with graph paper. This right now is just to help you understand what are translations, what are transformations, what applies to the vertical, what applies to the horizontal, and how to interpret them. Let's do this again for another parent function. Let's take a look at the parent function y equals the absolute value of x. Okay, so absolute value means that anything that was negative becomes positive. So if this just said y equals x, okay, that's the line that cuts right through the center of the first and third quadrants. When we make it absolute value, everything down here that was a negative y pops back up to become a positive. And so that's what our parent absolute value function looks like. So now let's start to translate, transform, and reflect it. The absolute value of x minus 6 plus 1. Okay, here's our parent. Negative 6, that is inside the absolute value sign applying to the x. That's right, horizontal, and horizontal happens, that's right, the opposite of what you would think. So minus 6 means 6 in that direction. Then we have a plus 1 on the outside of the absolute value sign. That's right, vertical, and vertical happens, that's right, exactly as we would think. So we're going to go up 1, and that's our final. Okay, one thing that's very important in translations, transformations, and reflections is the order of them. So go take a look now at this video, which explains to you the order to apply these things to your parabola or your absolute value. Leave in the comments anything you've got a question about. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.